Hi, it's Mr. DeCrane, and we're going to be talking about evaluating logarithms today. I've got 6 problems here on the screen, and what I'd like you to do is take just a minute and see if you can figure out what the values of these logarithm expressions are. Pause the video and try these out on your own first, and then come back and we'll talk about them. So pause and try them. Okay, hopefully you've tried them already, and let's talk about what each of these evaluates to. So first of all, in the first one, log base 3 of 9, remember that's just a number. If I'm not sure what it is, I can call it n, and I can say then, if I convert this to an exponential, that's 3, the base becomes the base of the exponential. The result of the logarithm, n, is the exponent equals 9. And so pretty quickly I can see 3 to what power gives me 9? That means n is 2. So log base 3 of 9 is 2. Because 2 is the exponent, that when I raise 3 to it, I get 9. I can do the same thing with the second one. Log base 2 of 1/16 means 2 to what power gives me 1/16. And again, if you're not sure, you can raise it, say that's equal to n, and I'm going to do the base 2 to the nth power equals 1/16. 2 to what power is 1/16? I know 2 to the 4th power is 16, because 2 times 2 times 2 times 2 is 16. But I want 1/16. Oh, remember reciprocals happen when I use negative powers. 2 to the negative 4th equals 1/16. So n equals negative 4. So log base 2 of 1/16 is negative 4, because 2 to the negative 4 power equals 1/16. All right, how about this one? Log base 4 of negative 1. 4 to what power gives us negative 1? Raising to a power usually means multiply over and over again, or divide over and over again. If I take 4 times 4 times 4 times 4, I'm going to get really big. If I do divided by 4, divided by 4, divided by 4, I'm going to get small, but it doesn't seem like it's going to go negative. If I say it's equal to n, I can rewrite it as an exponential. 4 to the n is negative 1. And I think to myself, wait a minute, 4 to the nth power, that's always positive. Remember the range on y equals 4 to the x. The graph of that looks like this. The y value is never negative. So 4 to the n equals negative 1, I can't solve that. There is no value of n that's going to make it equal to a negative number. So this one is undefined. I can't take the log of a negative number. If it had said log base 4 of 1, so 4 to what power gives me 1? If I say that's equal to n, I get 4 to the n equals 1. 4 to what power is 1? Oh, n is 0. So log base 4 of 1 equals 0, but log base 4 of negative 1 is undefined. I can't take the log of a negative number. By the way, you may have noticed that a couple of times here I've used parentheses around the argument of the log expression, and in the first case I didn't. It doesn't matter whether we use the parentheses or not. I tend to use them for clarity, though, to say this is the thing I'm taking the log of. Okay, log base 25 of 5. So again, 25 to what power gives me 5? So 25 to some power is going to give me 5. And I think to myself, wait a minute, 25, I can't do 25 times 25. That's really big. That's 625. If I start dividing by 25, I'm going to go 25 divided by 25 is 1, divided by 25 is 1/25. Where did the 5 come from? But remember that 5 is the square root of 25, right? And a square root is the same as raising something to the 1/2 power. So n is 1/2, so the log base 25 of 5 is going to be 1/2. That means take the square root. Okay, now this last one, log of 1,000, you're saying, hey, DeCrane, where's the base? Well, when we don't write a base, it's implied that the base is 10. This is called a common logarithm. And when we don't write a base in, we know that that's base 10. We do all kinds of things in base 10. That's how we count. But we can solve it the same way. 10 to some power gives me 1,000. So 10 to some power is 1,000. So 10 times 10 times 10 is 1,000. So n is 3. So log base 10 of 1,000 is 3. Or if I don't write the base, because I don't have to if it's base 10, log of 1,000 equals 3. This last one is interesting because, again, there's no base, and this is ln. It doesn't say log like we're used to seeing. Well, ln means natural logarithm, and the base, that means that the base is e, and we saw that a little bit when we were working with exponential function. Remember, e is about 2.718. So here we're saying e to some power gives us 50. And that's not something I expect you to be able to do off the top of your head like some of the other ones. I expect people to multiply by 10 over and over again to get to 100 or 1,000 or 10,000. But multiplying by this decimal, 2.718 and so on, over and over again, that's not something I expect you to know. So this one we would have to use a calculator for. When we use a calculator, I want you to notice that there's a log button on the calculator right here. But there's no base on that. That's a base 10. That log button on the calculator is a base 10 logarithm, a common logarithm. This one up here, ln, that's my natural logarithm. And on this particular calculator, I got to type in the number I'm going to do the log of first. I'm going to do log of 1,000 just to show you how that works. So I type in 1,000, and then I press the log key, and there's the 3. Log of 1,000 is 3, and this calculator even tells you what we're doing here. If I want to do the natural log of 50, I do 50, and I hit the ln button, natural log of 50. You can see it's an irrational number. The decimals go on forever and never repeat. So 3.912 is what this is approximately equal to. So I'm going to go back over here. The natural log of 50 is about 3.91, and I'm going to stop there. So that's how to evaluate logarithms. Have a good time with it.